The sun, our constant companion, our source of light and warmth. It's been burning for over 4.6 billion years, and without it, life on Earth would never have begun. But the sun, like all stars, is not eternal. It has a lifespan. And right now, it's almost halfway through it. Our star is a G-type main sequence star, often called a yellow dwarf. At its core, hydrogen atoms are being fused into helium through nuclear fusion, releasing tremendous energy. That energy radiates outward through layers of plasma until it reaches the surface, the photosphere, and shines into space. This balance between the outward force of fusion and the inward pull of gravity keeps the sun stable. But fusion won't last forever, and when the fuel begins to run out, that balance will break. In this chapter, we'll explore what stage the sun is in, how stars evolve, and what happens when a star like ours begins to die. Because the clock is ticking, even for the heart of our solar system. Roughly 5 billion years from now, the sun will begin to change. Slowly at first, then violently. As hydrogen in the sun's core becomes depleted, fusion will start to falter. Gravity will begin to compress the core, heating it further. Meanwhile, hydrogen fusion will ignite in a shell surrounding the core, and the sun will begin to swell. This is the beginning of the red giant phase. The sun will grow in size, first doubling, then tripling, and eventually ballooning to over 100 times its current diameter. It will engulf Mercury, it will swallow Venus. And Earth? That's a subject of debate. Some models suggest Earth might escape direct engulfment, pushed outward by solar mass loss, but it won't matter. The oceans will boil, the atmosphere will evaporate, the surface will be scorched. Earth will become uninhabitable long before it's consumed. From a distance, the red giant sun will be a magnificent sight, glowing red-orange, larger than any full moon ever seen. But up close, it will be deadly. The red giant phase won't last forever. It's a brief chapter, a few 100 million years, but during this time, the sun will shed its outer layers, casting off vast clouds of gas into space. And what remains at the core, that comes next. After the sun expels its outer layers in a spectacular display of gas and plasma, what remains behind is its naked core, a white-hot ember known as a white dwarf. No longer undergoing fusion, this stellar remnant no longer produces energy. It simply glows from residual heat, gradually cooling over billions, even trillions of years. A white dwarf is incredibly dense. It packs about half the mass of the sun into a sphere no larger than Earth. That's like squeezing the sun into a space the size of our planet. These remnants are faint and small but stable. They don't collapse further thanks to electron degeneracy pressure, the quantum mechanical force that holds the star up against gravity. Surrounding this corpse of a star is a glowing shell of expelled gas, a planetary nebula. Despite the name, it has nothing to do with planets. It's a halo of beauty, colourful, radiant and short-lived on cosmic scales. In a few tens of thousands of years, even that nebula will fade. The white dwarf, however, will remain, silently drifting through space. Eventually, it will cool into a black dwarf, a dead, dark sphere. But the universe isn't old enough for any black dwarfs to exist yet, not even close. This is how stars like our sun die, not with a bang, but with a long, fading whisper. Long before the sun enters its red giant phase, Earth's fate will already be sealed. Over the next billion years, the sun will gradually become brighter, about 10% more luminous every 1.1 billion years. This might sound small, but it has devastating consequences. With just a 10% increase in solar output, Earth's average temperature will rise dramatically. The oceans will begin to evaporate. More water vapor in the atmosphere traps more heat. A runaway greenhouse effect begins. Eventually, Earth may come to resemble Venus, scorched, dry, and uninhabitable. The habitable zone, that delicate region where liquid water can exist, will move farther out. Earth will be left behind, plants will die, oxygen levels will plummet, complex life will vanish, microbial life might persist for a while in sheltered niches, but even that won't last. By the time the sun begins to swell into a red giant, Earth will be a desolate, airless rock. If it's not engulfed, it will be roasted by solar winds and intense radiation. Could humanity escape? Could we migrate to Mars, the moons of Jupiter, or even Alpha Centauri? That depends not on the sun's timeline, but on ours. Because the end of Earth is not in question, only our presence on it is. If you could witness the death of our sun from a safe distance, say from a spacecraft beyond Pluto, the transformation would be unforgettable. At first, you'd see the sun growing steadily brighter over millions of years. It would change colour slightly, from yellow to white, as its temperature increases with age. Then, over thousands of years, it would expand dramatically, turning a deep red-orange. From space, it would look enormous. Its surface no longer sharp but swollen and blurred by the outer layers of gas it throws off. The sun would cast an eerie red light across the solar system. Mars might bask in what once warmed Earth. The asteroid belt would glow with a dull crimson hue. You'd watch the outer planets become more visible in the red light. Jupiter's clouds, Saturn's rings, and even the distant ice giants would be lit by a dying star. Then, after the red giant phase, you'd see a planetary nebula, a shimmering cloud of gas expanding in all directions like a cosmic flower. At its centre, a brilliant tiny dot, the white dwarf. Even from this distance, you'd feel a sense of cosmic loss. The system that gave birth to life, to Earth, to us, reduced to a quiet, fading ember. And yet in that chaos lies beauty. The expelled gas will enrich the galaxy with elements and carbon, oxygen, nitrogen that future stars and planets will inherit. The sun dies, but its ashes seed the next generation. If the sun is destined to destroy Earth, the next question is inevitable. Can humanity escape? The idea sounds like science fiction, but it's also a serious scientific question. If we want the human race to survive for billions of years, we'll eventually need to leave our home planet. The most immediate strategy? Colonize the solar system. Mars may be habitable for a time, especially as the sun warms up. The icy moons of Jupiter and Saturn, like Europa and Titan, may become more temperate as the sun swells. These worlds could offer temporary refuge, but it's not enough. The red giant sun will eventually make the entire solar system hostile. The long-term plan? Leave the solar system altogether. This would require technology we don't yet possess. Propulsion systems capable of interstellar travel, life support systems that can operate for centuries, and the ability to terraform or adapt to alien worlds. Some theorists suggest generation ships, vast, self-sustaining spacecraft where hundreds or thousands of humans live and die during a centuries-long voyage to nearby stars. Others imagine uploading human consciousness into machines or seeding the galaxy with autonomous probes that carry the blueprint of life itself. We don't have to solve it today, but if humanity wants to survive the death of the sun, we must become a multiplanetary, multistellar species, because staying here means writing our own extinction into the stars. Though the sun's death may seem like an ending, it's also a beginning. As it sheds its outer layers during the red giant phase, it releases not just gas, but a legacy, the elements forged in its core. Carbon, nitrogen and oxygen, the very ingredients of life, are cast out into the galaxy. These elements enrich the interstellar medium, the cosmic cloud from which new stars and planets are born. The sun's death, like so many stars before it, contributes to a galactic recycling process. Future solar systems will be born from this enriched material. And perhaps in one of them, life will rise again. Not just microbial, but intelligent, sentient and searching. Maybe they'll build telescopes, maybe they'll study the skies, maybe they'll find the remnants of our sun and wonder who lived here and why they vanished. The universe is vast, but everything is connected. Your atoms, the calcium in your bones, the iron in your blood, were born in stars like the sun. So when it dies, it does not end. It transforms. It passes on its legacy. The sun, in a very real way, becomes part of everything that follows. And perhaps that is the greatest comfort of all. If you enjoyed this journey through the life and death of our sun, there's so much more to explore. From black holes to distant galaxies, We're just getting started. Be sure to like this video, subscribe to Skyward Space Quest, and join us as we uncover the wonders of the cosmos, one star at a time. Thanks for watching.